The essence of creating fertility from infertile soil, like this soil here, which is a lot of what this block of land is. It's quite hard clay. When you try to dig it up, it clumps. It's non-structured clay. So all the topsoil was pushed off when this was cleared into the national park behind us. So what we're looking for is low-cost building of biomass, not just above the ground, but below the ground. So we want extensive root systems in the ground. We want lots of biomass on top of the ground that helps build the fertility and feeds the microorganisms. Because the microorganisms are the workforce of soil reconstruction. In good soils, in healthy soils, there's tonnage of microorganisms working to protect your productive plants. And building organic matter as humus, we have the long and short-term carbon, and we have all the associations with the organic matter and with the microorganisms, and the microorganisms deliver minerals and water to productive plants. And now the emerging conversation of the essential nature of mycorrhizal fungi with most of our productive plants is becoming more and more forefront of the conversation of agriculture, of biological agriculture. When we use chemical agriculture, we kill a lot of these mutualistic relationships. So in this practice, we're always building relationships with nature instead of destroying them. So this is regenerative agriculture. This is biological agriculture, where we use microbiology as the workforce. That saves us an immense amount of money and meets the requirements of how we define sustainable agriculture. And here we define sustainable agriculture as our ability to build soil fertility as we improve profitable production. And that, for me, is the future of agriculture if we're going to do it sustainably. Now, what I'm showing you here is biomass production on soil that a few weeks ago was bare clay with almost not even grass on it. So the soil a few weeks ago looked a lot like this patch here. Okay, so you can see that this area here has almost nothing growing on it because it's non-structured hard clay. So if you look at the amount of biomass here that's produced in 6 weeks, and all we did here was we put a couple of inches of compost mixed with a variety of seeds, and then in this case the cowpea took over. We have some sorghum and we have some lupin in the mix, but it's mostly been taken over by cowpea. If you look at this wall here of this is a fence, and behind the fence is a permaculture food forest. The permaculture food forest behind this fence, which protects it from kangaroos, is only 2 trees wide. There's only 2 rows of trees behind this fence. And then this is an example of intercropping. So we'll have all this as the perennial garden behind the fence, and we'll fence this in because this will be a annual cropping area. This will be a highly productive garden between the sections of food forest that will ultimately be created. And if we harvest this material, there'll be several cubic meters of mulch here that we can just mow and then plant amongst it. And then, of course, we have all the biomass of the roots below this system, and since it's a legume, it will release a lot of nitrogen and other minerals in the mix, and the growth on top will serve as mulch. If we harvest, this is a 1.5 meter fence. If we harvest the cowpea that's populated the fence, taken over the fence, we'll get about a cubic meter of biomass from this that we can use for mulch or compost. We harvest it pretty easily. And we get about a cubic meter every 6 meters of lineal length. And if we harvest it from both sides, it gives us a lot of material for mulch and for composting. And we leave the roots in the ground to decompose as a legume to give a burst of growth to the food forest inside this fence, which we'll show you later. So that's this section that we're talking about, and we'll add to this as we chop and drop this in the next couple days and show you what the food forest, the fruit trees behind the fence are like at this point, after they've been overgrown by the cowpea. And now that it's becoming a little bit cooler weather, they're going to be exposed to light. The nutrient in the roots of the cowpea and legumes are going to be released, and we'll get a burst of growth, which we will see as a powerful birth of growth in September, October, when the soil warms up again. So this is the subtropics. It's modeled for Christmas Island Farm, which is equatorial, which is warm all year round. But these same principles apply, and these same species will apply to Christmas Island as well. The fruit tree varieties will change a little bit, but not a lot, and we'll continue to document this in the next couple of days to show you the transformation process of the chop and drop and how well the fruit trees are developed. Okay, thank you. We make bio-vital compost, and this is more than 50% wood chips. And it's taken a while. This has taken 12 to 16 weeks to break down. We've turned it 4 times with a mini excavator, and this is the end product. So you can see it's quite a good product, and it's the basis of our fertility. This is what has given fertility. This is what has given the fertility for this cover crop behind us. Okay, so it's this compost that's given us that fertility. And that has had one application of compost tea, and this is of probably 6 or 7 weeks of growth that we're looking at now. If we look at this trellis, this fence, this is the fence that is protecting the food forest and the kangaroo. And we're going to chop and drop all this biomass today. And we'll show you the enormous amount of mulch that we get from it. And of course, the roots of these legumes will still remain in the soil and break down and deliver fertility to the trees. And it'll give them a lot more sun in these cooler months. So we expect a burst of growth, which we'll document over the next couple of months. We'll get a big burst of growth out of this. So as we go along, we'll continue to take video so we can put it together and show you the whole process. So you can see that in the last 10 minutes, we've dropped a tremendous amount of biomass. You can see the compost on the edge there, which we'll see in other photographs. And this is a banana circle, a permaculture banana circle, which is supposed to be the highest production of bananas as a system. We fill the middle of it, of the banana circle, with mulch, and that feeds the banana circle and maintains moisture, etc. We've these bananas were planted last March, so they're a year old. We've gotten 4 hands off of it. We have another 3 bunches ready to harvest, so we'll do that. We might harvest some bananas today. But look at how much biomass we've harvested from this legume on the legumes on the fence. This terrific amount of biomass that provides fertility and advances soil and feeds soil microorganisms and provides mulch. And in 10 minutes, we've harvested this much, which is 3 or 4 cubic meters. So this is a terrific resource at very low maintenance. So we put the seeds down and we harvest this now. This is the 4th time we've harvested this year. So we're advancing soil fertility very quickly by producing an enormous amount of biomass in the ground as the root system, above the ground as the leafy mass, and also we have all the microorganisms that it's associated with thriving and surviving in building the fertility in the soil, which we'll show you in the next part of the clip.